Hello again. Thanks for joining us. This is Space Nuts. Coming up, we're talking Lagrange points, supermassive black holes, dark matter, and a what-if question about meeting aliens and what we would want to know from them. All coming up on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Okay, Fred, shall we tackle some questions?
We should, shouldn't we? That would be nice.
Yeah, well, I guess so. Okay, well, we've got a couple of text questions to start off with. This one comes from Jim Skelly in Plano, Texas. It says, I have a question about Lagrange points. If we look at the 5 Lagrange points around the Earth and the Sun, I can fully comprehend L1, which is between the Sun and the Earth. I can also understand L4 and L5, which are 60 degrees ahead of and behind the Earth's orbit, respectively. Can readily see where the force of gravity between the Sun and the Earth would be in balance at these 3 locations. I really struggle to understand L3, which is on the opposite side of the Sun from the Earth, and L2, which is beyond the Earth and is a popular location for positioning telescopes like, the Planck,
JWST.
And the new European one that's gone up there too. I cannot understand how gravity between the Earth and the Sun is balanced at L2 and L3 locations. Can you kindly enlighten me? Thank you for the answer and the great podcast that you produce each week. Well, it's not great every week, I can tell you, but anyway, it's a bit sick today.
They know that, Andrew. You don't have to tell them it's not great every week. Everybody knows that.
But no, good question. And I must confess that this is one that confuses me as well. So that'd be very, very nice.
It's a fairly simple answer, actually, and you'll kick yourself.
So you say.
You'll kick yourself because there is another force involved.
Okay.
So you've got gravity, and yes, the L1 sitting between the two, 1.5 million kilometers towards the Sun from our own planet, which is that 1% of? It is. It's 1% of the distance to the Sun. Pretty well, exactly.
Okay.
So that's easy to understand, but the others are totally counterintuitive, especially the ones that are outside, the one that's outside the orbit of the Earth, L2. But the other force that comes into this is centrifugal force, because the Earth is moving around the Sun at 30 kilometers per second, takes 365.25 days to go around, and that generates an outward force, just as, spinning a wheel puts an outward force up. And it's the balance between that and the gravity that it's a marvelous thing, really. It's another of these wonderful natural phenomena that you don't expect. But the balance between centrifugal force and gravity gives you these 5 stable points, which are very useful.
So that's it. It's just centrifugal force.
Yeah. Yeah.
Someone's going to email us a question saying, "Okay, etc." But how? Why? I don't understand.
Well, let me just elaborate a little bit further. So if you think of L2, which is on the opposite side of the Earth from the Sun, 1.5 million kilometers away, that's being pulled directly inwards by the gravity of the Sun and the Earth.
Yeah,
because they're in a straight line. So the two of them are in a straight line. They're both pulling like mad with their giant gravity, but the centrifugal force is trying to push anything at that point outwards.
Oh, right. So you've got a resistance against the gravity. Gotcha.
And it's pretty well the same for L3 as well. Even though that's on the other side of the solar system, it's still feeling the gravitational pull of both the Earth and the Sun. The other two, they're a bit. I actually find L4 and L5 the hardest ones to understand intuitively, which Jim was saying are the ones he can understand. Because we've got we've got a sort of triangle of vectors. Basically, it's a pull by the Earth and by the Sun, forming a triangle like that. Here's the Sun pulling. Here's the Earth pulling. So you've got to point an object at the apex of the two vectors, if I can use a technical term, the pull. But once again, that is balanced by the centrifugal force as these things troll around the Earth's orbit. So it's very neat stuff, invented by a mathematician who probably never thought we'd ever use it for practical purposes.
Was his name Lagrange?
Very good. I think it's, was it Sid? No, it's Fred Lagrange. Yeah, that's it.
Fred. Of course, well, all the greats are called Fred.
Yes, that's right.
All right, thanks for the question, Jim. Our next question comes from Kerry. Hi, Andrew and Fred. Excellent podcast. Keep up the great work. The following has been nagging me for some time. How is the gravitational effect of supermassive black holes and dark matter on galaxies separately determined? If both are impacting a galaxy, how is the specific mass of a supermassive black hole determined? Could an incorrect estimation of the mass of supermassive black holes be the cause of the need to include dark matter, i.e., are the actual masses of supermassive black holes big enough to cause the gravitational effect that has prompted the need to include the dark matter component? Looking forward to hearing your views. And Kerry, thanks for putting supermassive black holes in the question 4 times.
It's all right. You can get your tongue around that, Andrew. You're a radio podcaster. Yeah. It is a great question. But the two are separate enough that they can be measured with pretty high precision separately. So if you've got a galaxy, you can, with a supermassive black hole at its center, and if it works best for what we call active black holes, ones that are gobbling up their surroundings. So there's gas and dust which is whizzing around the black hole at relativistic speeds close to the speed of light, and those speeds can be measured. And so what you can do is actually you can sense that very close to the black hole there is a very high gravitational pull, and that's what the speed of rotation of the accretion disk tells you. It tells you that there's an enormous gravitational pull, and that's really, it's far into the center of the supermassive black hole. And that phenomenon, when you get, I don't know, even only 100 light years away on some supermassive black holes, it would be more than that, but you don't have to go far away before it disappears. So this is very much an effect due to the black hole itself. Whereas the effect on the galaxy, and if you take the simplest example, and we've got many, many observations of different kinds that tell us that there is something missing there, that dark matter is real. When you look at the rotation of the whole galaxy, and you look at what would cause that, the mass distribution that would cause that, it's not concentrated at the middle. You can work out what the distribution of matter is by the rotation, and you find that it's a blob, which is all around the galaxy, but it's quite separate from what the black hole measurements are. It's a good question, though. I like it.
Yeah. Okay. Thank you, Kerry. I hope that helped. But yes, there's obvious signs that differentiate them, is what Fred said, which would have been a shorter answer. But
we've got to stretch the program out somewhere, Andrew.
Yes, that's true, actually. Thank you, Kerry. All right. Our next question, which we had to dump last week due to time constraints, we're going to tackle now. This is a what if question from Robert.
Hello, Fred and Andrew. This is Robert from the Netherlands. I would like to propose a thought experiment for us. We've made a connection with a very superior alien race, but because it's done through a superconducting computer, I only ask one question. You two fine gentlemen have been selected. So what will it be? It can be the winning lottery numbers. You can't ask anything else, science related, the dark energy, Big Bang, cure for aging, how to stop time, travel back in time, anything you like. please let me know, and I'll be listening.
Okay, thank you, Robert. Only one question. Oh, look, I did some research on this, Fred, and I couldn't think of an intelligent scientific question to ask, and I actually went to one of my favourite social media sites, Reddit, to see what people would say, because Reddit people are a little bit weird compared to other social media, and I got a few ideas, but I do remember that the Harvard Gazette did actually hone in on this via our good friend Avi Loeb, and they made a point of saying, well, your first stumbling block's going to be language. Language is going to be the first major hurdle to overcome when it comes to speaking to another interstellar race. And I don't know if you've seen the movie Arrival. Arrival was a film where these creatures came to Earth in their spaceships and sort of planted themselves all over the world, and they had to get a linguist in to try and decipher their language so we could find out what they wanted. And of course, Earth being Earth, we went on ready alert and we're going to blow them all up. So there was a time limit on how this would be resolved. It was a very clever film, and not only that, it had a time element that completely confused me until the very end, and I went, that explains why the story's all weird. But that's the first problem. I probably wouldn't ask a scientific question straight up. I'd leave that to the Fred Watsons of the world. I'd want to ask them more rudimentary stuff, like how do you live day to day? What's your civilization like? Yeah. Do you have religion? Do you live in houses and have streets and get garbage collected? That's the stuff I'd want to know. That's exactly what goes through my brain. What is their lifestyle? Not very scientific, but then again, I suppose
I think that's really important, and it's the sort of thing you should ask. The trouble is, the answer you might get to a question like that could be 42.
Yes,
because that's where it goes a bit wonky.
Yeah.
I'd like to. Thanks. Sorry, did I interrupt you there?
No.
Okay. I mean, at some level, I think we'd be asking the same question, but maybe framed in a different way. Because I would like to know, at the moment, let's step back a bit. At the moment, our best understanding of reality, the way the universe works on big and small scales, is the two theories, the two pillars of our understanding of the universe. General relativity, about things on big scales, gravity and all that stuff, Lagrange points, all of that. General relativity and quantum mechanics, which is things being in two places at once, and curious things like that. And things, when you look at one in one place, you immediately know what the other one looks like in the other place. So those are incompatible. And a lot of physicists in particular have suggested that there is a deeper theory, some deeper theory that maybe quantum mechanics and relativity emerge out of. And it could be, that there are things that we simply don't understand at all. One is gravity. We know the way it behaves because relativity tells us that. We've no idea what it is. So we postulate it might be gravitons, but we haven't discovered them yet. And the other one is time. We've got no idea what time is. It's a unit in four-dimensional space-time. You can see it in the equations. You find this term, which is c squared t squared, coming up in these equations, and that tells you that time's a dimension. But beyond that, we really don't know much about it. And so the thinking is that theory that underpins everything might explain things like time, things like gravity, things like why quantum mechanics is incompatible with general relativity. And it might really be the answer to life, the universe, and everything. It's often called a theory of everything. We don't have it.
So your question would be, have you guys figured this stuff out?
Yeah,
we
that's
don't
right.
have a clue.
Yeah. But where it where it overlaps what you said, they might say, yeah, we have actually, and we call it religion. You know, these are such deep questions. We really don't know the answer to them. And so I think there's a lot of really pointed questions you could ask. Robert says we can only have one question. Since there's two of us, that means we can have two, and they might tell us something they didn't know.
And it's very sad, Robert, to have to admit that being humans, and we get this contact and we can ask one question, and the guy on Earth at the telescope who receives it goes, can you hang on a second? Too late, done. Because that's what had happened.
Yeah, I do agree with you. Arrival was a very good movie. I really enjoyed that.
Brilliant film.
Most science fiction movies irritate me enormously, but that one didn't. I thought it was really good.
It's so deep. Yeah. So deep, very cleverly constructed film, and you've got to concentrate. You can't go away and make a cup of tea because you come back and go, what's happened? What's happened?
Andrew, I can never do that, I'm afraid. I lose the track of things so quickly. It takes about 2 milliseconds and I've lost the track, so I've got to concentrate on everything.
My wife, and I'm talking quietly because she's just out there, my wife will watch a half-hour show after lunch and not finish it for 3 or 4 hours because she keeps stopping it to go and do little jobs around the house. And that's how she spends her afternoon. I'm going to watch a half-hour show, start at 12, and by the time I'm finished doing these things around the house, it'll be 4 o'clock and the show will be finished.
I think there's a lot to be said for that.
That's time management, isn't it?
Yeah, it's time management of the kind that I simply don't have. I don't think you needed to lower your voice there. I think that was a compliment. Hope you're listening, Judy.
She didn't bang on the door, so I'm safe. No. Look, I could go on with ideas about this question from Robert for forever. The questions just keep coming to mind, and you could ask squillions of questions and still not scratch the surface about anything really. But it is a great question, and one we might get to tackle again further down the track as we are older and wiser. Robert, thank you very much for the question. Don't forget, if you have a question, send it in to us, whether it's by audio or text through our website, spacenutspodcast.com, spacenuts.io. If you're a YouTuber and you've just found us, please subscribe. We would. I've always wanted to do this. Click on the subscribe button below. Never done that before because they all do that. But yes, please subscribe. We'd love to get more people on board through YouTube. But whatever platform you're viewing or listening to us on, we really appreciate your support, particularly those who are patrons that put a little bit of money into the place to keep the lights on and pay Hugh's enormous salary. And Fred, that brings us to the end of yet another show. Thank you very, very much.
It's a pleasure. I think it might have brightened up my health a bit, having this. Very good. Often that's all you need is get out of your mind, get out of your misery.
Yeah, absolutely. Keep yourself occupied and you feel a lot better. Very true. Thanks, Fred. We'll catch you next week.
Sounds great.
And thanks to Hugh in the studio for reasons that don't come to mind, but I'm going to get the telescope out and ask an alien what Hugh does. And until next week, looking forward to your company on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at bytes.com.
This has been another quality podcast production from bytes.com.